Hey guys, welcome to a new video in this computer vision tutorial. In this video here, we're going to do 3D object detection with the MediaPipe module that we've been using in the previous videos here as well. In this video here, we're going to actually have an object that we're tracking around in the image frame, and then we're doing a 3D object detection. So we're drawing a 3D bounding box around that object instead of only 2D bounding boxes as we're used to. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can come chat with us about computer vision, deep learning, and so on. You can also become a member of the channel here if you want to support the channel more than you're currently doing with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So let's now jump into the code here, where I'm going to show you how we can set up this MediaPipe module here, so we can use the machine learning solutions that they have built into that module. So first of all here, we need to import OpenCV because we're going to use OpenCV to load in an image from our webcam, and then we're going to do some operations by converting it back and forth between RGB and BER. And then at the end, we're going to show the image and the actual detections, the 3D object detection that we're tracking with OpenCV here as well. So first of all, we're importing OpenCV, and we're also importing the MediaPipe module here as MP. So when we're going to use the MediaPipe module here, we're just going to reference it as MP, and then we're going to import time here because we're going to time the algorithm or the detection that we're running, so we can see the number of FPS that we get by running this machine learning solution here on a CPU. So first of all here, we need to set up both the objection for the 3D object detection, and we also need to set up our drawing tools as we did in the previous videos. So first of all here, we're going to have MP underscore here, and then we're going to have this objection here. So we're going to have object tron, and we set that equal to the MP here dot MP from the solutions here. We go inside the solution to the solutions class here, and then inside the solution class here, where we have like all the built-in detectors. So down here we are going to have this MP.solutions dot objection, because we need this objection here, which is the 3D object detection machine learning solution here in MediaPipe. And then we're going to set up our MP underscore drawing utilities here as well. So we're just going to have MP underscore drawing. We're going to set that equal to MP.solutions again. So we're going to the solutions, and we'll get the drawing utilities by MP.solutions dot drawing underscore utils. So now we have set everything up with these two lines of code here, where we now actually like have an object of these different kind of things. So we both have our objection here for the 3D object detection, and then we have our drawing utilities, which is actually like the utilities that is going to draw the 3D bounding boxes of the object that we're going to detect and track around in the image frame. Then we're going to go down here and open up our video capture here. So it's just the 0th element. So I'm just going to open up the webcam here on my computer, and then the capture here, or like the video capture from the webcam, will be stored in this cap variable over here to the left, where we can then read in an image from the webcam later on. Then we're going to open up this objection that we just created up here. So we have this MP underscore objection, and then we have this method here built into objection, where we can do some different kind of like configurations for this objection or the 3D object detection algorithm. So first of all here, we're going to set the static image mode here equal to false, because we're going to have actually like a video sequence running that we're going to do this 3D detection on. We can also set the maximum number of objects, or the maximum number of objects that we want to try to like draw the bounding box around and have this 3D detection running on. So I'm just going to set that equal to 2 in this example here, but you can just set it to whatever you want. We also have a minimum detection confidence here. So this is just threshold values both for minimum detection confidence and also for the minimum tracking confidence. So if you're over this threshold here, then we actually like say that this is a detection or like a true detection in our image frame. So we can play around with these parameters here to try to avoid false positives and stuff like that. And if you're not detecting anything in your image frame, you should maybe lower these thresholds here a bit, so it will take into more account and try to detect more objects in the image frame. We also need to set up the model name here, so what type of object they actually like want to do object detection or like 3D object detection on. So in this example here, we're both going to do object detection of a cop and also a shoe, as I'm going to show you at the end of this video here. We're just going to open up this objection 3D object detection algorithm here as objection. So later on, when we're going to use the actual like methods built into this objection class here, then we can just use this objection here to actually like access those methods. Then we're going to go down here into a while loop. So while our capture is open, so while our webcam is open here on the computer, then we're just going to, first of all, we're going to read in an image from our webcam. We're going to store the image in this image variable, and then we're returning this success variable. So it is either true or false if we're able to read in an image frame from our webcam. Then we're going to start a timer, so we can actually like start time how long it takes to actually like process our image and have this 3D object detection algorithm running. Then we need to convert our image from BGR to RGB, because when we're loading in our image with OpenCV, it is actually like loaded in as BGR, but MediaPipe's machine learning solutions operate with RGB images, so we need to convert that from BGR to RGB first of all. Then we can set this image.flags.writable, so we are not able to write to our image when we're actually like passing it through this process function over here. So it improves the performance a bit, and we're passing the image as a reference instead, and we can write to that image when we're actually like going to process down here. Then to actually like get the 3D object detections, we're just going to have this object that we just created up here. And then we're going to call this method here .process, and then we're just pass in the image that we want to process and do the 3D object detections on. Everything will be stored, like all the information about the coordinates in the image frame, the pixel or like the image coordinates for the pixels, and also just all the boundary box values will be stored in this results variable here that we can then use later on to actually like use our drawing utilities to draw that 3D boundary box around the object that we're both detecting and tracking around in the image frame. Then we set our image here to writable again, so we're actually like able to draw on top of that image with the boundary box that we just detected and stored in this results variable up here. Then we're going to convert our image back to BGR from RGB, so we can actually like display what is going on in our image with OpenCV. So now we can go down here and actually like get the detections or like check if we have any detections here in our image frame. So first of all, here we're just going to have this if statement here. So we have if results. So we're going to use the results here, and we're just going to check if we have any results. So we can have this results.detected objects. So we're just going to check if we're actually like even detecting some objects in our image frame. And if we're detecting objects in our image frame, we're just going to have a for loop that is running through all the detected objects in our image frame. And in this example here, we have a maximum of 2 objects because we set that up in the configuration. So down here, we just have a for loop where we're running through like our detected objects. So we're just going to have this detected underscore objects, and we're going to run this inside this if statement or like this statement up here. So we have this results.detected objects. So we have our for loop running through all the objects in this results variable up here. So now we're going to go down here and actually like use the drawing utilities to draw the landmarks for the 3D boundary box that we're detecting. So down here in the for loop, we're just going to use the drawing utilities. So we have this mp underscore drawing, and then inside of this mp underscore drawing, we have a method called draw landmarks. So we're just going to call this draw underscore landmarks. So now we have this method here where we're going to specify first of all the image that we want to draw on with our drawing utilities, and then we have the detected objects here. So the detected object that we're running through now. So in case of we're detecting 2 objects, we will have one of the objects here in the first and in the for loop the first time we run through it. And then if we're tracking another object in that, it will come after we have run through all this code here and drawn our landmarks here on our image frame. But in this example here, we're just going to detect one object in our image frame. So we have this for loop here just running through that that detection or like that 3D detection. We're going to draw the landmarks here on this image, and this is the objects that we're going to draw. And then we actually need to specify like how we're going to translate around like or like how we're going to connect the boxes that we're tracking. So we have these detected objects here where we're going to actually like be able to draw. So we have this detected objects. We need to get the landmarks from the 3D detected objects that we have. So we're going to have this landmarks here. So we're going to landmarks underscore 2D. So we both want to get the both like the 2D or like the boundary box for 2D, and then later on we're actually like going to draw on an axis to get the third dimension for our 3D object detection. So we have the detected objects here dot landmark underscore 2D, and then we need to specify how we want to connect these boxes here. So we're just going to have mp underscore objection, and then we're going to use something called box underscore connection. So this is just how we're going to connect the boxes in between each other. So now we have set everything up here for the 2D boundary boxes that we're detecting in our image frame. And the last thing here that we're going to use is the like drawing the third axis, so we get the third 3D object detection. So here we can just use the mp underscore drawing here utilities here again. And then we have a method called draw underscore axis. So we're going to draw an additional axis in our image frame so we can get the 3D boundary box. We're going to specify the image where we want to draw this axis here on. And then we're just going into the detected object here again. And instead of the detected object, we're just going to have detected object here because this is only one object that we're tracking in our image frame. And then we're going into here and use something called rotation. So how the 3D bounding box, or like how the object is rotated around in our image frame, because we're going to use that information to actually like be able to draw our third dimension or our 3D bounding box. So we have this detected object dot rotation, and then at the end here we're going to specify how that object is translated in the image frame here as well. So we have the detected object here again, and then both rotation and translation here at the end. So we're going to have translation. So now we have actually like everything set up here for our detections. So if we're detecting anything, we're going to have this for loop running through all of our different kind of objects detected. We're going to draw the landmarks, and we're going to draw the actual like axis, or like how our 3D bounding box is, both rotation wise and translation wise. So now we have everything here. We're drawing our 3D bounding box on our image here on the object that we're detecting. And then on here at the end, we're just going to end our timer. We're going to get the total time, and with the total time, we can calculate the number of FPS. So how efficient and how good our algorithm here is running. So we have our FPS here, which is equal to 1 over the total time, and we're just going to put that number of frames per second that we get each time we're processing an image. We're going to display that on top of our image as well, so we can see the performance of our algorithm. Down here at the bottom, we're just going to show the image here where we're actually like drawing our 3D bounding boxes on. And then at the end here, if we hit escape, we'll just break out this while loop here that we created, and we release our capture here. So we're releasing our webcam so we can use it later on again. So now we're going to run the program here and see some different kind of objects here that we're tracking around in the image frame. So first of all, here we will open up the window. Right now, we're not tracking any objects here around in the image frame. But in this case here, we have specified that we want to track the object, or like the cup, around in image frame. So if I have a cup here, we can see that we're now drawing this 3D bounding box here. We can see that we get like a coordinate system of in the middle of our object that we're tracking. And then we're using the rotation and the translation of our objects here to actually like be able to draw this 3D bounding box around our object. And we can see that we're tracking it pretty good when we're moving it around here in the image frame. And if we try to like remove the cup handle here, like it doesn't really see it as a cup anymore. So it kind of needs like this cup handle here to be able, and if I block it too much with my hand here, it doesn't detect it anyway. But we can try to play around with some of these parameters for the confidence score, and we might be able to get some better results here with our object detection, or like a 3D object detection. But we can see like it's pretty nice. It is rotating around with the cup here as well while it's tracking it and doing this 3D object detection, or like the 3D pose object detection of this object here in our image frame. So the second thing here that I'm going to show is just the shoe object. So we need to go up here again to the model name, and then we're going to specify the shoe. And then when we actually like have this specified here, we can just run our program again, and then we can try to see if we can track around a shoe in the image frame here instead. So I have a shoe here that we just get up here, and we can see that again we are nicely detecting the shoe here in the image frame. And if I rotate it around here, we can see that we're still trying to estimate the pose, or like the 3D pose here of our object. And if I move it around, like we can see that we're still tracking it. It loses some tracking like sometimes, but we can play around with the parameters as I just said with the cup as well. But it's really nice. It's a real nice and cool machine learning solution here, and we can see that we get like around 20 to 30 FPS here running on a standard and normal CPU in this example here. So yeah, that's pretty much it for this video here, guys. We've been over like how we can set up this 3D object detection here with MediaPipe and OpenCV. We went over some examples, and at the end here, I showed you like how we can actually like detect these 3D poses of our object and drawing these 3D bounding boxes around them as well. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more in future, because it just really helps me and the YouTube channel out in a massive way. I'm currently doing a deep learning tutorial where we're talking about like convolutional neural networks, the basics about that, and how we can create them from scratch, training on a data set, and how we can do predictions on data that hasn't seen before. So we're actually combining both computer vision and deep learning together with these machine learning solutions here as well from MediaPipe. So if you're interested in going more into depth with deep learning, I'll link to the tutorial up here, or else I'll just see you next video, guys. Bye for now.